Alright guys, today's goal: the learner will understand polynomial functions of higher degree with modeling. Okay, so what you're going to learn about: graphs of polynomial functions, end behaviors, zeros, intermediate value theorems, and modeling. And why these topics are important in modeling and can be used to provide approximations to more complicated functions, as you will see if you study calculus. The vocabulary. Each monomial is the sum. In the sum is a term of the polynomial. A polynomial function written in this way with terms is descending degree, is written in standard form. The constants are the coefficients, and the term is the leading term, and a sub naught is the constant term. So let's take a look. What they're talking about is if you have this 3x to the fifth plus 4x squared minus 9x plus 5. So the degree would be 5. And see how it goes 5, 2, 1, 0? That's the constant. The leading term is the 3. And when it says terms, count. You have 1, 2, 3, 4 terms. That's what they're talking about. But standard form, because it goes highest degree to lowest degree. That's how you should always write answers. That's how everything should always be written. Describe how you transform the graph from an appropriate monomial function, f of x equals a sub n x to the n, into the graph of h of x equals negative times the quantity x plus 2 to the fourth plus 5. So if you think about this, our parent function, consider it this. So the negative means it's reflected over the x-axis. It was moved left 2 units because of the plus 2 and up 5. Remember, we've been going over these, okay? And it says compute the y-intercept. How do you compute a y-intercept? Well, x is 0, so plug in 0 and solve. So you get y equals negative 0 plus 2 to the fourth plus 5. That would be negative 16 plus 5, so the y-intercept is negative 11, so that's 0, comma, negative 11. Okay? Let's see if we were right. So you could obtain by shifting 2 units left, 5 units up. It just didn't even include the reflection that we know about. And the y-intercept is negative 11. Okay? Cubic functions. Here's some basic designs. This is when it's greater than 0. That's when it's less than 0. Okay? See how it flips? Quartic functions. Open up when it's positive, down when it's negative. Local extreme and zeros. A polynomial function of degree n has at most n minus 1 local extremas and at most n zeros. So if you think, what they're saying is if you have f of x equals x to the third, that means you have at most 2 extrema, so minimum maximums, and at most 3 zeros. It's possible to have zeros, it's possible to have 1, 2, or 3 for them, but at most 3. Okay? Limits as x approaches positive or negative infinity. Okay? Just, this is something you're going to need to look at and to study. So if we look at this, notice something. For odd degrees, they're always opposites. For even degrees, they're the same. They're either both positive, both negative, but what they're saying about is, as x goes to positive infinity, so as we're moving to the right, what is y doing? It's going up. As we move left, what is the y doing? It's going down. So that's why it's positive infinity, negative infinity. Here, as we move to the right, what is the y doing as we keep moving right? It's going to positive infinity. As we move to the left, what is the y value doing as we move to the left? It's going to positive infinity. That's what they mean. Okay? Odds are opposites. Okay? And if it's an odd degree greater than 0, positive, positive, negative, negative. If it's an odd degree and a is less than 0, switch it. Same thing with the evens, okay? So an example of this would be x to the third. Example of this, negative x to the third. X to the fourth, negative 3x to the fourth. Okay? Describe the end behavior using limits. Okay. So identify A. A is 2, even. So it's greater than 0 and it is 2. So you would say the limit of f of x as x approaches negative infinity equals positive infinity. Because remember, even and above 0 means they both open up. And then the limit as f of x approaches positive infinity. They equal each other, so positive infinity. So let's see if we're right. The limit of g of x, see how it says plus or minus equals infinity? So yeah, we got it. Okay, find the zeros. Okay, so first thing when I think about zeros is I factor. So what do I have to do? Try to factor out what we have in common here. So I know I can factor out a 2x. I would get x squared minus 2x minus 1. So I have equals 0. So I know I have 1. 2x equals 0. Divide by 2. So you have one of them, x equals 0. Now here, is there anything that multiplies the negative 1 and adds the negative 2? No. So, except this wouldn't be 1. This would be 3. So yes, we still have the 2x. Is there anything that multiplies the negative 3 and adds a negative 2? Yeah. X minus 3, x plus 1. So now you have the 2x equals 0, you have x minus 3 equals 0, x plus 1 equals 0. X equals 3, x equals negative 1. So there's our 3 zeros. Another way for quadratic functions, which is after we factored out the 2x, you could have used quadratic formula. There's a lot of different ways we've learned. Let's see if we're right. 0, negative 1, and 3. Yep. Least to greatest. Good job. Alright, if f is a polynomial function, the quantity x minus c to the m is a factor of f, but x minus c to the m plus 1 is not, then c is a 0 of the multiplicity of m of f. We'll talk about that, see what that means later. Alright, sketching a graph of a factored polynomial. Well, this gives us 2 points at least, because you can say x plus 2 equals 0, and you can say x minus 1 equals 0. Cube root it, so you get x equals negative 2. Square root and solve, and you're going to get x equals 1. Now, this is where we have to think. So this is just a sketch, not exact. So I know I can go negative 2, and I know I can go positive 1. And I know the end behavior here is going to go negative infinity. And the end behavior here is going to go positive infinity, because A is 1, because if you multiply that out, it'd be 1. So that means this. It went something like that. You can pick more points if you want, or check in your calculator to finish the sketch, but there's a quick sketch, so let's see what it looks like. See, I wasn't exact, but see how it goes negative, positive, infinity? So it says the zeros are -2 and 1. The graph crosses the x-axis -2 because the multiplicity is 3 and on. The graph does not cross the x-axis at x equals 1 because it is 2 and it is even. So it didn't completely cross it. It goes back up. Okay? If a and b are real numbers with a less than b, if f is continuous on the interval from a to b, then f takes on every value between f of a and f of b. In other words, if y sub naught is between f of a and f of b, then y sub naught equals f of c. For the same number in c and a and b. Okay, we'll talk about that in class, but so remind me to do an example of intermediate value theorem tomorrow. I'll talk to you guys later.